next presentation will be made again by Dmitry Kochergin. He will speak about PHOTOMOD and useful additional utilities. Yes, the theme of my presentation is indeed about some useful additional utilities developed by the company Racurs. I can brag that mostly they're developed by the technical support department and not the development department. Most of them were the utilities for internal use, but then we looked at them and see that they're quite useful, and we decided to publish them and post them on the web page. And it's good that all of them are free of charge. Now you can see the list of these new utilities. I will speak more about each one of them. First, the calculation of Gauss-Kruger projection parameters, calculation of coordinate system transformation parameters, estimation accuracy of the on-ground from on-board exterior to orientation parameters, calculation of grid step DTM for contour lines and orthomosaics of selected accuracy, calculation of intersection angles and overlaps for the aerial survey and coordinate values, recalculation between coordinate systems. And I added also here the calculator, which is known by many PHOTOMOD users. It doesn't belong to these utilities, but it proves to be quite popular. Where to find them? Here on our web page you can see the tab, and using this link you can download all of this. Now a bit more about each one of these utilities. Calculation of Gauss-Kruger projection parameters, for instance. It was prepared for Krasovsky ellipsoid, well-known parameters. This is the meridian and the shift, full systems, full nothing on X and Y axis. Because often the standard parameters which you can put into the standard calculator can be inaccurate. People trip over it all the time, and there could be difficulties on the longitude and latitude, and here they're used mostly for local coordinate systems. This is what it looks like in terms of the interface, the set of control points, and here you can see calculated parameters. Many people might notice that this is not SK 63. Now about the calculation of coordinate system and transformation parameters. How they're scaled up, it's a bit trickier here. You can see different options. There could be geocentrical coordinates, geodesical coordinate, or rectangular coordinates, and depending on what we have as an input and output, we have different chains of internal recalculations, how this program works. Here you can see the illustration of these parameters that we calculate. In fact, there are the elements of external orientation, and that's how it works in terms of the interface. As a rule, naturally, they're used for internal or local systems of coordinates. Here you can see the geodesical coordinates, longitude, latitude, and altitude, and some of the conditional systems of coordinates.
So we computed parameters. Moving on. It's an interesting utility. It's very simple. You have onboard system, GPSMU, which operates with certain accuracy declared by the manufacturer. So everyone is interested, just what will we get on the ground without using GCPs by using the onboard IMU. So this utility allows you, by using survey and imaging parameters, to calculate accuracies on the ground. So here's your imaging parameters, camera parameters. You don't have to set any super accurate values, and the resultant values which the system should deliver, supposed to deliver. In fact, why is it called stereo measurement accuracy? Because this is the accuracy which the operator, by wearing glasses, will be able to detect or measure using stereo pair. Now, another frequently asked question: how do we calculate if we want to build an orthophoto? Before that, we want to have a DEM, and there's always a question of what is the spacing. How do we usually do it? We build a grid, then we set its spacing, meter, 3 or 5 meters, then we generate DEM. The denser the grid is, the higher the accuracies are, but we don't need any redundancy because it takes longer to edit. So it's preferable to know that if we have the outgoing scale like that, or output scale, like here, for example, and there is another parameter of graphical accuracy, it can be different. It's either 0.5 or 0.7, depending on this map scale. You can set it yourself. And then there's parameters of imaging and certain terrain features or terrain slope. So you can get a great step. The same applies to the horizontal. And you can see that for orthophoto is much bigger. So the model can be much more rough. Calculating angles of intersection and overlaps. For that, there is dedicated software, but we have our own easy-to-use, simple utility that we developed depending on what your overlap is, what camera you use, what's the X to base factor is. So you can set the angle of intersection. You can even check what happens if you set the angle of intersection at 30 degrees, whether or not you'll be able to fly with proper overlapping. We can see that the overlap of 54, which is less than 60%, so there's a warning for you that this is not good. And another very simple utility that we use, maybe we shouldn't even have included it. So by setting an area size, you can then use a camera, pro camera or UAV, how much time will be needed to cover it. Of course, we could have added a 3 camera, but we have several central projection cameras. So it will show you how many days it will take to do coverage. It could be 130 hours or 3,000 hours. So this will give you a feeling of what can or should be used. There will be a master class on that the day after tomorrow, so you'll be able to get all these details then. Besides, during our conferences, we practice this thing in parallel to the plenary session. We can set up a computer in the hallway and you can come up to me and ask for questions. Maybe you brought your own data that you need to process, and so we're willing and open to help you out with that. So that's all. That's all I have. Thank you very much. Distinguished colleagues, we did fine in terms of schedule. I have a question about the density of points for orthophoto and horizontals or contours. What formulas are used? It's not a trivial task. The main formula is taken from the manual, from guidelines on photogrammetric works. Okay, let's say So the formula allows for a Z error. Then you have to set your terrain. I'm just curious. I mean, I'd like to make comparisons with what I have. It'll be interesting, I'm sure. You know, I looked over several articles and they seem to be controversial. They contradict one another. Various approaches are used. And thirdly, I will gladly share with you A3 data. Once again, it's not trivial. I think we're done for today, right? Let's call it a day. Let's thank Dmitry once again.